So 1.3, common factoring. So you guys had your lesson, or you had your quiz yesterday. Quiz marks were posted last night online. Some of you did see your results, some of you didn't. You'll get your quizzes back on Monday. I'm still waiting for 2 people who were absent yesterday to write. So you'll get your quizzes back on Monday. On Monday, you'll see the mistakes and you'll who and ha and him and ha, whatever. We'll go through all that on Monday. I get the fact that, however, some of you saw your mark and you were quite pleased with your result. Some of you perhaps saw your mark and it was so-so. Some of you saw your mark and you were devastated by it. I get that. All that stuff is normal, especially at the start of the year. It's quite possible you got a result that you just weren't satisfied with, you weren't happy with, and maybe the result you got yesterday is actually much lower than you've ever received in the past. I mean, it's quite possible maybe you failed the first quiz and you've never failed anything in your life. That's okay. I am not worried about it. I didn't lose any sleep over it. I don't panic. I'm not concerned. It's not like I went home last night and cried myself to sleep and my pillowcase is covered in tears. That's not the case at all. It really doesn't make a whole lot of difference. How you did on the first quiz is just a snapshot. And what's going to happen on Monday when I give it back, you'll see a whole lot of frustrating mistakes that you made. And you'll realize that most of us, the vast majority of us, you know what you're doing. You just lost 2 marks there, 2 marks there, 2 marks there, 3 marks there, 2 marks there, 2 marks there. And when you get it back, it was clear, like, you understand fundamentally what you're doing, but you wrote a 4 instead of a 5. A negative over here turned to a positive over here. Or on the short answer, I can't tell you the number of people who actually have the answer written correctly down here, and then when their pencil wrote it in the answer space, they wrote the wrong number. So many small mistakes that you're going to end up seeing on Monday, which are fine. It's frustrating, but the small mistakes are fine. However, there may be a couple of you guys who actually did have a really difficult time in the quiz. Maybe we'll have an individual chat about that. But generally speaking, the first quiz, whether it goes well or it doesn't, it really just shows me how things are going generally. And generally, things should be going pretty good, regardless of the small frustrating mistakes. 1.3, common factoring. We're now going to sort of enter this series of lessons where we're going to do a total of 7 different methods of doing something. Over the course of those methods, I'll show you different ways of doing things. Some will be better than others. Some might be more advantaged in certain situations and some not so much. Basically, what I'm trying to say is I'm going to give you some strategies. Each individual strategy that I give you, each individual lesson that I give you will be fine. Today's lesson will be fine. I might lose a couple of people at the end, but generally speaking, today's lesson will be fine. Tomorrow's lesson will be fine. Then when we keep on going, it's going to start piling up. And you might notice that somewhere in about 2 to 3 lessons from now, you might feel like you're getting a little lost. It's because something wasn't clicking at the beginning. So over the course of this lesson, if you find that you have yourself a question, just raise your hand and ask. And if you're worried about, I don't want to embarrass myself, it's going to be on YouTube, whatever, then no problem. Just make a little note and come see me at lunch tomorrow or something like that. But definitely ask for that help. Don't let it sit longer than it needs to. Common factoring. In order for me to do this, I will tell you that everything we're going to do in this lesson for the first bit is technically review. You guys are the last class that I'm having today. As I was working through the other classes, I said that it's supposed to be review at the beginning. But it turns out that I think some of your grade 9 teachers didn't necessarily go through all of this. If you had Mrs. Botros, I think you're fine. But I'm not sure if everyone else actually went through all the nitty-gritty. So instead of just assuming it's review, let's just back it up and start from the beginning. Don't write this down, just follow along. If you had the number 24, 3-4 years ago, your teacher might have said, ooh, let's make a factor tree. And your teacher might have said, let's break this 24 into different numbers that multiply to give you 24. So you might say 4 and 6. 4 and 6 are 2 numbers that when you multiply these, you get 24. And your teacher would say, good, that's good. That's a partial factor tree. But we can continue this because each branch of this tree has a leaf on it at the end. But those leaves can go further. This 4 can be broken up into a 2 times a 2, and a 6 can be broken up into 2 times a 3. And when you get this is now your complete factor tree. And what I'm circling right now are the prime factors, the smallest building blocks of 24. So when you take 2 times 2 times 2 times 3 in any order, you end up with the same 24. But we could have started this differently. We could have started off with the 24 and said, you know what, sir, I didn't like the 4 times 6. I want to do it 8 times 3 instead. No problem. because we'll end up at the same point. Because this 8 is really a 4 times a 2, and this 4 is really a 2 times a 2, and lo and behold, we have the same 2, 2, 2, and 3 in a different order or not, perhaps, but we end up in the same position. That's what I'm trying to get at earlier when I said I'll show you different strategies, and we're going to have different ways of doing it, but hopefully we'll still arrive at the same ending. This process of what you guys did before, this idea of a factor tree, where you took something big and broke it up into small pieces, that's what factoring is. Let's get back to the lesson. Factoring means to break up into smaller multiplicative parts. Multiplicative parts. Into smaller multiplicative parts. That's not a fantastic definition, because in this process, I've used a word, parts, that's not really a math word. There is a math word for it, which I'll get to as we go through the examples. But that's the idea. That's what we want to do today. I want to take something big and break it into something small. Let's look at our first example. This first example and the first few examples should be grade 9 review, but if it's not, that's okay. That's why we're going through it. Let's factor. Let's do 4x cubed plus 28x squared. 4x cubed plus 28x squared. I'm going to use this example. I'll draw a bunch of arrows, different colors, so I can explain different pieces of this. We'll make sure we lay down the foundation, and we'll pick up the pace after this. Now, before we even start this question, let's just talk about what we have right now. We should know what kind of a polynomial we have, because it's a question that we've already talked about. What kind of a polynomial do you have here? Emiliano. Binomial? Why do you say binomial? Two numbers? I agree, binomial for sure. I agree, this is definitely a binomial. His reason, because there's two numbers, it's not the best. I think he's thinking about it correctly, but just maybe didn't find the right words for it. Why would you say this is a binomial? It's not two numbers. Grace? Two terms. It's a binomial because it has two terms. Terms is the actual math word for it. Okay, so let's follow that up. For those of you that see that this is a binomial that has two terms, where are the terms? I want to make sure we're clear about this, because maybe you're saying it's 2 because there's a number 2 there, and that's not it at all. Where are the two terms here? Celeste? I mean, yes, but let's look at the entire thing with it. The 4x cubed and the 28x squared are the two terms. I'm saying that because I want us to be able to recognize, without much thinking, that it's the addition or subtraction that separates the terms. The addition or subtraction sign is what separates the individual terms. That's a big deal moving forward, because I'm going to talk about that afterwards. So this is a binomial. We can see there's two algebraic terms. Okay. Look at both algebraic terms and find the biggest thing that can be divided evenly out of both terms. Celeste?
4.
More.
4.
I agree. More.
X squared.
4x squared. Now, if you see that, great. If you don't see it, no problem. I'll talk more about it in the upcoming examples. But 4x squared is the biggest thing you can divide out of both terms of my binomial. When you divide that 4x squared out, you're going to be left with something. The leftover is literally what happens when you divide that 4x squared out, when you remove it. That leftover in this case is going to be x plus 7. Now, I haven't given you much indication as to where that came from on purpose, just so I can assess. When you look at this, to go from this step to this step, who does remember doing this last year? Well, it's not everyone. Okay, it's actually the minority, perhaps, maybe even half. So it's not perhaps everyone that went from here to here that did factoring. You should have done some common factoring last year. Maybe it was one class, It could have been up to a week. I think Mrs. Botros probably did the most of everyone. If you haven't seen this, okay, then we'll do a little bit more practice before we get into it. I just want to continue, before I do the next example, just to talk about what I see right here. I want to point out this thing, this 4x squared, in the past you'd refer to it as the GCF. GCF is not an actual acronym in math. It's called the greatest common factor. Greatest common factor. So that's the greatest common factor. As a result of removing that greatest common factor, I have an x plus 7 as my leftover. This x plus 7 is my leftover binomial. Leftover binomial. Now, the line that I have there, my answer, I'll talk a little bit more about this in the upcoming examples, but what I'd like you to do is just look at that last line right there. Imagine this circle wasn't around here. In fact, how about I just quickly just get rid of the circles just so I don't want us to focus on this. Okay, let's take a look at the answer here. And I'll ask you a question that's going to be rhetorical, which means I don't want to hear an answer. Don't raise your hand. Just think about it. Just think about what your answer could be. If you look at the final answer right there, how many factors do you see? How many factors do you see? Think about that. And if you're not sure about what the question is even meaning, okay, how about I change it up? How about if I say this? How many pieces of information are being multiplied? Ooh, still not sure? Again, it's rhetorical. So still not sure? Let me ask you a different question then. Remember how earlier we realized this was the binomial because the addition and subtraction separated the terms? How about if I were to tell you, imagine where the hidden multiplication symbols are here, and that helps you separate the factors. So imagine where the hidden multiplication symbols are, and then count up the factors. If you do that, you'll see there are 3 factors. There are 3 factors here. Let me underline them for you. 1, 2, 3. There are 3 factors in this answer. This idea of identifying the factors, remember how we identified the terms earlier? This idea of identifying the factors is not important for us right now. It's not. I'm just kind of laying the groundwork for the future. How do I know they're factors? Again, it's being separated by an imaginary multiplication. Separated by a multiplication. There is an implied hidden multiplication symbol right there between the 4 and the x squared, and another one right here between the x squared and the x plus 7. That allows me to say there are 3 factors. Another way of thinking about it is imagine where some brackets would be. I could put a bracket around the 4, I could put a bracket around the x squared, and that creates my 3 factors. So this is our goal today, is to do, well, this and a lot more, because this technically was grade 9. That's okay, let's continue with the grade 9. Let's change it up ever so slightly. I don't know why I just wrote number 2. I guess that was number 1. Number 2. 24x squared minus 54x cubed. In some respects, it's remarkably similar to number 1. In other respects, it's perhaps a little bit different. Now, in the first example, some of you don't need an explanation. Celeste gave me this answer, and I think it made sense to her. And maybe just looking at that, of course that makes sense to you. It's so obvious. But I didn't really tell you how we came up with this number. So let's didn't say where the 4 or the x squared came from. So let's talk more about that in this example. Let's look for the greatest common factor. Let's talk about how. To find the greatest common factor, let's focus on the coefficients first. Here are the coefficients, the 24 and the negative 54. Figure out the biggest number that can be divided evenly into both of them. Now look, ideally, you can do some math in your head, but of course you have a calculator, and ideally you can get this answer relatively quickly. If you're looking at this thinking, no problem, it's 2, because they're both even numbers. I disagree. 2 is a common factor, but it's not the greatest common factor. There's a bigger number. Then you might say, oh, I get it, it's 5. Where are you coming up with that from? It can never be 5. I'm hoping that we realize we wouldn't even bother testing 5. I wouldn't sit there and think 24 divided by 5 gives me what, 54 divided by 5 gives me what. Because I'm hoping we realize that neither 24 or 54 are divisible by 5 evenly. So don't bother testing those. You wouldn't test 10, but somewhere along the way, again, you either know it because you know your multiplication table, or you can quickly get on your calculator and you realize it's 6. Then look at the variables, pardon me. I've got an x squared and x cubed. Now it happens to be the same ones as over there, just in reverse order. That may or may not change something. There was an x cubed, then an x squared. Now I've got an x squared, now an x cubed. Let's find the greatest common factor. It happens to be the same thing. X squared is the greatest common factor. The leftover. The leftover is the leftover that exists when you divide the original binomial by the 6x squared. I'm hoping we don't actually have to write that down anywhere or do it in the margin somewhere. I'm hoping we can do it. So let's just do this without writing anything down. 24 divided by 6 is 4. X squared divided by x squared, well, we don't have to worry about that. That disappeared. Negative 54 divided by 6 is a negative 9. X cubed divided by x squared gives me an x leftover. There is my answer. So the coefficient here, I came up with that because it was the largest number that was divisible into it. But this x squared, something weird is happening. Earlier, I called this the greatest common factor, which is what it is. It is the greatest common factor. 4x squared was the greatest common factor here. 6x squared is the greatest common factor there. When you look at the word greatest, most of us think greatest means biggest. It does. Greatest means biggest. Biggest means highest. Greatest means biggest and highest. So then, isn't a cube bigger than a squared? Shouldn't that be x cubed there? Shouldn't that have been an x cubed there? Seems counterintuitive. And you? Yeah, it's not just greatest, it's greatest common. They have to have it in common. There have to be enough x's for you to take out of both of them. So that ends up being the smallest exponent. It's always going to be the smallest exponent, helps you figure out the greatest common factor for the variable. So the coefficient, yeah, just figure the biggest number. But for the variable, just look for the smallest exponent. This process of going from this step to this step, this is what I say. When I say factor, this is what I mean. And a synonym for factor, another word to think of what factoring is, it's really just to divide. Which seems weird. Because you might look at this and say, isn't that the opposite of what we should be doing? Because if you look at all the questions that we've done so far, earlier this year, last year in grade 9, grade 8, grade 7, when you had algebra, your whole goal would be to simplify. You would start with this and finish with this. The process of going from here to here, that's what simplification is, to simplify. To simplify means to multiply. And now I'm asking you to do this in reverse, which is counterintuitive. At some point in your lives, you've all baked a cake. First thing you do, you get some ingredients together. You get some flour, some sugar, maybe a little pinch of salt, some baking powder. You get all your dry ingredients together, perhaps over here. Over here, you get all your wet ingredients together. Crack a couple of eggs, you've got your milk, maybe some vanilla extract or something. You get all your dry ingredients, wet ingredients, mix it all together, put it in the oven, and you get a cake. We've all baked a cake, I think. If you haven't, live a little, please. Bake a cake. Go home tonight. Homework. Bake a cake. Have you ever unbaked a cake? Take a cake out and start ripping it apart to get the eggs and the milk and the flour. That's like counterintuitive. Why would you ever unbake a cake? Let alone the fact that to unbake a cake is really hard to do. Technically not impossible. You actually need some high-end equipment, but you could technically unbake a cake. But why? Why in the world? This is what I'm asking you to do. I'm asking you to take a cake and unbake it so you can get its individual pieces. You've been trained for the last 3 years to take the individual pieces and put it together to make a cake. I'm asking you to reverse the process, which is, again, counterintuitive. If you're thinking, well, why? What's the point? Why do this if we've been trained to do this and now I'm asking you to go backwards? Good question. I can't answer that until Tuesday. I'm going to have to do a little bit of work to get to that. On Tuesday, we'll do lesson 1.5, the most important lesson of the year. Signal handling, most important lesson of the year. Not hard, just most important. But in that lesson, we'll address why we're doing this, the whole point of this. It's just going to take me a little bit of time. So for us today, we're doing it without a reason. And then when we get to Tuesday next week, we'll see the reason as to why we're doing it. Okay, when I look at this, I'll ask the same rhetorical question I asked earlier. Rhetorical means just think of the answer. When you look at the answer here, how many factors do you see? How many factors do you see? 3 again. 1, 2, 3 factors. There are 3 factors. Not because it's always going to be 3. Just because that one had 3 and this one has 3 doesn't mean that's always the case. Just because it's a binomial doesn't always make it a 3. It depends on the question. This idea of identifying the factors, 1, 2, 3, is not a big deal for us right now. But on Tuesday, when we get to why, it'll be a much bigger deal. Let's continue. Number 3. We're still in the grade 9 stuff. And I'm just making sure we have all the tools necessary to transfer into the grade 10 stuff. Number 3, let's see, we've got 18x cubed plus 20x squared minus 2x. Are we still recording? This question has similarities and differences compared to the previous one. But we did this for long division. The questions looked, it's kind of different from now and then, but fundamentally it was the same thing. Same thing's going to happen here. It might look different. It might look very different by the end of the lesson, but it's really just the same thing. First thing I want to do, just before we even do any work, I want to point out that we should definitely know that this is a trinomial. There are 3 algebraic terms here. I can see there's 3 algebraic terms because the addition and subtraction separates those terms. So 1, 2, 3 terms. That idea of being able to identify those terms is going to be more important as we make these questions a little bit more challenging. Okay, look at each individual term. Let's start with the coefficients. By the way, don't forget to put an equal sign there. Those equal signs are important. We spoke about that before. Some of you forgot the equal signs on your quiz. On the long answer specifically. Let's see, 18x cubed plus 20. Oh, make sure you write it down correctly too, by the way. Because if you don't write it down correctly, it's impossible for us to continue. Oh, by the way, some of you did that on your quiz. You just wrote down the question wrong. A 2 in one step turned into a 3 in the next step. A positive over here turned into a negative over here. So let's make sure we do that. Okay, so I've got the question written down correctly. Let's look at all the coefficients. 18, 20, and 2. I think it's obvious 2 is the biggest number that's divisible into each one. Look at the exponents of the variables. I've got a cubed, I've got a squared, and I've got an x to the power of 1, so it's just x. So there's my greatest common factor, 2x. The leftover. If you're not sure, let's do this together. 18 divided by 2 is 9. X cubed divided by x is x squared. We've done a whole lot of math at this point. That should be okay. Let's continue. 20 divided by 2 is 10. X squared divided by x is x. 2x divided by 2x is the same thing. They disappear. They cancel each other out. We have our answer. That's wrong. That's not it. Why not? Camden.
Because the minus 2x, divided by the 2x is actually minus 1.
So when you divide something by itself, it doesn't just disappear. Anything divided by itself, you're left with a 1. In this case, it's a negative version divided by itself, you're left with a negative 1. I'm pointing that out because question 1A on the quiz, a lot of you forgot that. There was an extra 1 kicking around that maybe you forgot. And then we lose the silly 2 marks here. You'll get your quizzes back on Monday, you'll see it. So there's a negative 1 right there. There, I'm done. Rhetorical question again. I don't need to hear an answer, just think about it. How many factors do you see? It's 3 again. Let me help you out. 1, 2, there's still 3 factors. It's true, this one happens to be a lot bigger than the other one, but there's still 3 factors. Madam? What?
It was almost empty.
We haven't talked about it. Monday we'll be talking about the jail. Grace?
So whatever it's in the brackets, that's just considered one factor.
Yep. The entire thing in the brackets is considered one factor. And that leftover should match the number of terms that you're starting with. So I started with 3 terms. Yeah, I definitely should have 3 terms in there. I won't ask you to. I'll never ask you to, but you could check your work. Some of us should have checked the work on the division. You were getting some weird remainders. I don't know where they were coming from. You should have checked your work if you wanted to. Here, you could definitely check your work. If you multiply that times that, you should end up with that. I won't ask you to, but you can check your work.
The stuff in the brackets be in brackets too. Like, you know what I'm talking about?
Yes and no. I'll address this at the end because we have to build towards some stuff. The answer is yes, and then we can perhaps do something else with it. Okay, so let's continue. Number 4. Number 4 would be as hard as grade 9 would get. And then we get to number 5, and we'll get to the grade 10 stuff. So number 4 is our last sort of grade 9 version before we continue. Number 4. Negative 42a cubed b to the power of 4 c squared minus 49a squared b cubed c plus 14b squared c. Yeah. Earlier I said the first challenge is making sure you write down correctly. Yeah, I guess that's a problem here. Just don't get lost in those exponents. Negative 42, negative 49, 14, and the rest of it. So if you did do this in grade 9, yeah, you would have done. This guy's getting in the way maybe for some of us. I can see Eva kind of doing this maybe a little bit, looking around the unicorn. Okay. Look at the coefficients, look at the variables, take it from there. Again, ideally, if you look at the coefficients, you know your multiplication table well enough that you can get the numbers pretty quickly, or at the very least, you can just quickly get it on a calculator. When you're checking the calculator, again, please don't divide by 2. Why are you checking 2? 49 is an odd number. It's not divisible by 2. Don't check 4, don't check 6, don't check 8, because 49 is an odd number. It's not going to be divisible by 2, 4, 6, 8. So it can only really check, I don't know why you would check 1 either. Check 3 perhaps. Why would you check 5? Skip 5. Check 6. Like there are numbers that you should check numbers and not ones that other, you know what I mean. Check the ones that make the most sense. Grace. Yeah, go ahead. Perfect. What about the variables? What about the variables? Yeah, or if you have an answer. I don't know.
Just like C.
Just C. Are we good with it? Not so good with it? Oh, Louis is vigorously shaking his head. Louis, why not?
Well, 14b squared.
There's no A there, which means there shouldn't be an A here. So I guess earlier I did say look at the small exponent. The smallest exponent looks like it's an A squared, but you have to consider that there's no A. It's kind of like saying A to the power of 0. So A is not a common factor here. So it looks like it should be a B squared C. Let's continue. That'll leave us with a negative 6a cubed b squared c minus 7a squared b plus 2. There. So unless I've made a small mistake, which is always possible, it looks like that's it. Or maybe it's not. Sometime, hopefully a long time ago, you learned how to ride a bike. It'd be devastating if you don't know how to ride a bike. But hopefully you learned how to ride a bike. You got a bike. I don't know, you were 4, 5, 6 years old. Your dad, mom, grandfather, uncle, older sister, whatever, maybe taught you how to ride a bike. You sat on the seat, you got your hands on the handlebar, and you pedaled and you went forward, riding a bike. Pretty straightforward. But there's always one person, maybe 2 people in this class, who decide to do things differently and decide to ride the bike differently. You sat on the bike backwards, you put your hands on the handlebars, and you rode like this. Why? Why would you do that? Well, because, sir, that made sense to me. That's how my brain works. Some of us have brains that ride the bike backwards. We just see things a little bit differently. So you may look at this question and say, I didn't do it that way. I did it this way. You should absolutely see the difference, and you should absolutely recognize that it's the same thing. In this case, I decide to take out a negative common factor. Negative common factor. And as a result of taking out a negative common factor, my leftover is the same thing with a different sign. But we know it's the same thing. There is no difference between these two. They're both correct. They're both identical. They're both fine. For me, when I look at this question, I prefer this. For whatever reason, my brain likes to see this because my brain really hates seeing a negative after a bracket. It just gives me the heebie-jeebies. I don't like that. So my brain sees this better than that. But maybe you like this better than that. It makes no difference. However, remember when we were doing add the extra column for the long division? Some of us really liked it. Some of us didn't. Or if we had to rearrange something, some of us had to rearrange it. Some of us didn't even bother because you don't have to rearrange anything. Same thing here. Some of you prefer that, some of you won't. However, I'll point out that you might find it advantageous to do this. I'm putting that out there in the ether so that when you do your homework tonight, you'll think about something like that. Number 5, let's get to the grade 10 stuff. X times x plus 5 plus 3 times x plus 5. This now looks different. Although someone this morning said that in Mrs. Botro's class you did this, which would be cool. X times x plus 5 plus 3 times x plus 5. Your instincts could be wrong. We're so used to baking a cake. I'm asking you to unbake it. So if you're looking at this thinking, oh yeah, x times x is x squared, x times... No. That would be simplifying. I don't want you to do that. I don't want you to simplify. So I do not want you to say x times x is x squared, that's 5x, that's 3x, that's 15. That's the exact opposite of what we want to do. We still want to factor this. So as tempting as that is, we don't want to do that. We want to find a way to break it up into its smaller multiplicative parts. The problem here is at the beginning of the lesson, I asked you how many terms you saw. You said binomial or trinomial because the addition or subtraction separated it. Here, it's harder to see. It's there, but it's harder. Because what I currently have is not really a simplified polynomial. I don't have a simplified polynomial. So if you look at this and say, oh, sir, it's a binomial, it's a trinomial. Actually, it's not. You can't even define it because it's not really a simplified polynomial. However, if you think about it the same way, the addition and subtraction separates the chunks of information that you're working with. If you see that, then you'll realize that it's not really, but it's kind of like you have two terms. I'm going to put two terms in quotations because it's not really a term, but you can think about it that way. There are two pieces of information that are being added or subtracted. And I'll help you out even more. I'll show them to you. 1 and 2. Those are the two bits of information that I'm currently working with. The part that I underlined on the left and the part that I underlined on the right with an addition or subtraction between. In this case, it's an addition between. So just like before, when we had these guys over here, we looked at the entire expression, we found each individual piece, we found the greatest common factor, and then the leftover. Let's do the same thing, even though it's going to look very different. Look at the part on the left that I underlined and the part on the right that I underlined, and find something they have in common. This is very visual. You can literally see it. Celeste. Right there, and there, They literally both have an x plus 5 in brackets. Now, if you want to say, oh, but sir, there's more. This x, and they've got an x right there. No, 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 because this x is in a relationship. Don't break him up. He's with the x plus 5. This x is solo, fine. But this and this are not the same thing. But the entire x plus 5 bracket and the entire x plus 5 bracket, that is the same. Which means the x plus 5 is your greatest common factor. Well, let's think about this earlier. Where did we put the greatest common factor? We wrote it in the front. Let's do the same thing. Let's take that x plus 5 and write it in the front. So now I've got a binomial common factor. Binomial common factor. Whereas before, we had a monomial common factor. Monomial common factor, binomial common factor. The same thing happened for division. It was easy when you're dividing by a monomial. It got harder when you had to divide by a binomial. Same thing here. It's easier when you have a monomial, a little bit harder with a binomial. Let's just use the same idea though. Once we took out the greatest common factor, this big old bracket here was the leftover. We should have a leftover here. So let's have a bracket with the leftover. So again, this is the leftover. I refer to it as leftover. It's really just another expression. I'll say this mathematically and then I'll demonstrate this. So mathematically, what are you doing? You're taking the original expression and you're dividing an x plus 5 out of the original expression. So take that and divide that out. For some of you, that'll make a lot of sense just by me saying it. Most of us, that doesn't make too much sense. So let me demonstrate it differently. If I take this first expression and divide the x plus 5 out, if I remove it, let me do it. Don't do this in your notes, but let me do it. There. I took it out there, and I took it out there. My leftover should literally be the leftover. X plus 3. There's my second bracket. I now have factors that, unlike before where I have these individual monomials and this thing left over here, I don't have monomials anymore, which perhaps makes this question a little bit different. The rhetorical question I asked before, and I'll ask again, so just think about this. How many factors do you see? 2. 1, 2 factors. The brackets are the factors. Not a big deal for us right now, but Tuesday's class next week, super big deal. Someone this morning was asking me, is it always going to be like that? I mean, yes, fundamentally, but then it was Olivier who said, well, what happens in this scenario or that scenario or brackets? I'm going to see if I can try to address a little bit of that. Number 6. I think this will be our last one. Unless we can fit number 7, but I think we're going to stop at number 6. We'll see. 3x times x minus 2 plus 6 times an x minus 2. There are an infinite number of questions that can be asked in an infinite number of ways this year. It's impossible for me to show you an infinite number of ways. But what I can show you is just try to show you as much as possible so that if you encounter something you haven't seen before, you still have the pieces to put it together. You can still do it on your own. If you just look at that question and look at, let me put this x plus 5 back in. These questions are not identical, but they're remarkably similar. Remarkably similar. So if you look at the entire expression, you kind of have 2 terms again. Let me help you out. This thing plus this thing. Find the greatest common factor. Just like that is pretty clear. You can see that this entire x minus 2 chunk of information is the same. So an x minus 2. The leftover. If you can see the leftover, great. If you have to cross something off in your sheet of paper or if you wanted me to erase it on the board, you can imagine it being the same thing. If you look at the leftover, if you take out the x minus 2, just delete it from there, and delete that x minus 2, you can literally see what's left over. You'll have a 3x and a 6. I'm going to write this incorrectly. A 3x and a 6. That's written incorrectly on purpose. Plus. No. This is written incorrectly. Right? There's an addition sign with the 6, right? If there was a subtraction with the 6, I'd write it. There was an addition, I'd write it. So there should be an addition sign. And you can see it's the same question, the same layout, the same everything. And yet this one's wrong. Oh, it's wrong. That one's fine, this one's not. This is good, it's not great because it's not complete. Ooh, that's why it's wrong. It's not complete. We can go further with it. We can go further with it. Celeste was kind of tippy-toeing around it when she said something about whatever she had said. Grace? No. I like what you said when you started that. It's because you can divide it by it. Juliana? There it is. If you look at your factors here, you have two factors. 1, 2. If you look at your second factor, 3x plus 6, that itself can be factored again. That's what we want to do, factor it again. If you're wondering, well, how do you factor it again? Imagine the 3x plus 6 was a question just by itself. In fact, here, let me write it over here just for kicks. Imagine we just had a 3x plus 6 just by itself. And I were to ask you, just factor that. You'd say, okay, no problem. Let's see what they both have in common. I can divide them both by 3. What's the smallest exponent for the x? Looks like it's nothing because that doesn't even have an x. So there's my greatest common factor. Let's see the leftover. If I take 3x divided by 3, I'm going to left with an x. Let's take a 6 divided by 3, I'm left with a plus 2. Which means 3x plus 6 factors into 3 times x plus 2. I've broken it up into its ingredients. I've unbaked the cake. So that means this 3x plus 6, I can go further with it. I'm going to keep the x minus 2 because I have not been able to do anything with that. I can't go further with this. I can't break it up even smaller. But the 3x plus 6 I can. It's because the 3, I can put the 3 there and I'm left with an x plus 2 because that's exactly what I wrote. But this, which is right, this is correct, looks really weird. What's with this random solo 3 in the middle? It's bizarre. So some of you will not want to write this. It's fine, it's correct. Some of you might prefer putting a nice little bracket around the 3 because it feels better being protected with a bracket. Whereas some of you will do what I prefer. I prefer just taking that 3 because we know this is multiplication. It's all reversible. I personally prefer writing the 3 monomial at the beginning. That's just kind of how my brain works. But they're all technically the same. I will tell you, if you write it this way, you will absolutely confuse yourself in the future. So my suggestion, do this, or even better, you probably want to do this. As things get more complicated, this definitely makes the most sense. That's the fully factored answer for the original question. Liana. It doesn't make a difference. Multiplication in the order doesn't make a difference. Whether you do first and second or second and third, it's all irrelevant. We'll leave it there. Your homework tonight is going to start off fine. It looks long. Worksheet 7, questions 2 to 5. It's like, holy cow, sir, this is long. It's going to be like seconds to do the beginning. And then somewhere towards question 4, if you're going to have a problem, then it's going to happen number 4. Number 5 could virtually be impossible for us. That's done on purpose. Can you stop, please?